This particular activity is one of the favorites but most frustrating because they have to actually do everything perfectly correctly in order to get the cards to light. And it can be very frustrating because by the time they finish, they're going to have a very rudimentary understanding of circuits, so it's hard for them to troubleshoot. And you're going to have to be the troubleshooter. So just so that you know that. So I'm going to start off, first of all, again, all of these kind of go together. When we put the PowerPoints together, we really try to make sure that they all kind of lead them through this electricity journey. So hopefully, by the time you get to this, they'll be able to tell you some things that they remember about electricity. Hopefully, maybe they'll remember about valence electrons and so forth. I did not put those extra slides in here, but you could very easily in your copy and paste them over. You could show the animation of the copper wiring and so forth, and just remind them of what they know. But they should be able to tell you that maybe why we use copper wire and so forth, because you'll notice on the little lights that you picked up, copper wire. If you were to pick up other types of like things that they have to play around with electricity, you're going to see copper. Copper is a really, really common tool for electricity. We are going to be, and I like to preview this ahead of time because we've done electricity now a couple of times, and I want to go, okay, we're going to do electricity again, but this is what we're going to do. We're going to make some light up cards, and I'll put it up there and go, these are some possibilities, and they'll ask some questions, but they at least know the goal in the end, because that's important. So here's my picture of copper wire, and I would say, what is going on here? Why are we seeing this? Because we've already seen this. And we're going to take this one step further and just go, in order to get the best flow, we need to make sure that we're using the right materials. We want to use copper wire because it loses that valence electron really easily, and it's going to create a good flow. The more electrical flow we have, the better we're going to be able to use it for work. And then we're going to talk about conductors and insulators. Now, in the other two lessons, we have not talked about this. We've talked around it, but we haven't talked about it. And in this particular session, when you're making a card, they have to be thinking about conductors and insulators, because the electricity does not go through the insulator. So if there is not a path for the electricity, there's not something that's a conductor in the path, it's not going to flow, and they're not going to light up their card. So talking about, and this would be the place where I'd be like, take out your Stellar Girls notebooks, let's write down the word conductor, what do you think that means? Write it down. Insulator, what do you think that means? We've looked at a whole bunch, so they should know paper does not conduct. Copper wiring conducts. You know, these things that they've already seen, because those are the same materials that we're going to be using. So we want to make sure that they know this. Now, in order to light our card, we are going to take a battery, like the one that we built. We are going to create a path of conductance, but we're going to send it through a light bulb so that the light bulb lights out. And then we're going to connect it back to the battery so that it completes the circle. So I'm going to play this little video.
Let's begin by looking at how a simple circuit allows a light bulb to light. A circuit is a route through which electrical current can flow. In our example, electrons flow from the negative side of a D-cell battery to a conducting material on the base of the bulb. From there, the electrons flow up a wire that is inside the bulb and across the filament, which is the part of the bulb that actually lights. When the electrons go through the filament, some of the electrical energy is changed to heat and light energy. The electrons continue down another small wire inside the bulb to another conductor on the base of the bulb. The electrons finally make their way to the positive side of the battery. There would not be a complete circuit if the electrons did not travel to the positive side of the battery, and the bulb would not light. When there is an unbroken path on which electrons flow, as in this example, it is called a complete circuit. The unbroken path that the electrons follow is called a closed circuit, because electricity will only flow on an unbroken path. The light bulb will not light unless there is a closed circuit. Now look closely at the light bulb, and you'll notice that there is an insulator between the conductor that leads up to the filament and the conductor that leads away from the filament. Remember that the atoms of conductors easily accept and pass on electrons. The atoms of insulators do not. As we discussed in the first section of the lesson, electrons will not easily pass through insulating material that surrounds a wire. If an insulator did not surround a wire carrying a current, it is possible for the electron flow to get directed to another conductor that comes into contact with the circuit. Electricity will follow the path of least resistance. If the electrons take a path short of the complete circuit, it is called a short circuit.
Okay, now all of that is going to be super important for them to be able to understand, because that is like one of the major problems with these cards is that the tape that they're going to use with the copper is not insulated on either side, which means that if it's close enough to another piece of copper, it is going to short circuit and they're not going to see anything. And sometimes it's hard to see where it's short circuited because they're making these lovely little arty pieces and there's stuff all over the place. So I'm going to suggest, even though it's not in the actual written thing, that you do what we have right here and just make sure that they understand what the circuit looks like. So you should be able to, and almost everybody has already done this, but you should be able, these by the way, these are just Christmas lights. They're old Christmas lights. Just so that you know, you cannot use LED Christmas lights on these little batteries. There's not enough power in this little battery to light up those big LED Christmas lights. And they don't look big, but they're big for LED lights. So an old incandescent type Christmas light, you can just dismantle them. You want to make sure that you strip them a little bit down at the bottom because they're not going to be able to do that, and just have them here, right? So if in order to complete the circuit, we want to set it up like this, okay? So you've got these two pieces. You want to have one part of the wire on the positive part and one on the negative part, and it's a little tricky to do, you know, it's a little tough sometimes to do that. Now, as they do this, holding the copper wire to the battery, because this battery is so small, it isn't going to affect them in any way, but they should be able to light the battery. The better the battery is, obviously, the brighter the light's going to be. But doing that to begin with may help them to understand what they're going to be trying to do. So it's pretty easy to see here that it's a circular circuit, just like in the video. Inside this light bulb, in between these two wires, now these two wires, you can see that they're covered with insulating material and they go up, and then it's bare up here, and then it comes back down. And if you just talk to them about what it is they're seeing, that's going to make the circuit easier. The older your girls are, the less you really need to do this. It really depends on you and the experience of your girls. So you'll have to decide. Some of them have never, ever done this. Now you guys all kind of went, oh, and did what you needed to do, but it is possible that they're going to do something like this, or they're just going to do something like this. They may not know what that looks like. So they can kind of play around with it and they'll figure out how to light it, but they need to make sure that they can get the light done. So that's what it is. They need to make sure that they realize that this is a complete circuit. So you want to use the vocabulary as much as you can, because when you're helping them to troubleshoot, it's helpful to use the to use the vocabulary to make sure you're communicating. So this is a picture of what a circuit looks like. We are going to be creating a circuit with these little tiny LED lights. They are little tiny sticker lights that the LED is super, super tiny, and it looks like this. Actually, we'll have a picture in a minute, but it looks kind of like this. The LED is this little thing that sticks up here, and then we have the two sides. This is the positive side, this is the negative side. This is a piece of plastic in between here. It's an insulator. So that the metal, you'll see that there's metal down here, copper here, and then there's a little tiny wire that goes through that you can't really see very well, but it allows the current to go through the LED. But there's insulator here. And these particular ones, now lots of adhesive that you can find that are usually used on things is an insulator as well. Adhesive tape is an insulator. So these happen to use a conductive adhesive. But if something happens and the girls start putting tape on there, the tape is going to insulate it. It's not going to work, if that makes sense. So if the tape goes underneath in some way, they may not even realize it's doing that, but they just insulated the entire thing and nothing's going to travel through it. So this is what the simplest closed circuit looks like. And this, I like using the actual the way that they actually do it in notation scientifically. I like them to see that. They're 7th and 8th graders in my classroom, 6th, 7th, and 8th graders. It might not be necessary to do this in the lower grades, but I personally think there's nothing wrong with them knowing what that looks like. So this is the sign for a battery right here. They labeled the positive and negative. So it's going to go through. It's going to go through the LED light, and then it's going to come back to the other side. So this is the same circuit that we just saw with our battery and our light bulb. But this is also what we're going to need to do with our little LED. So we need to have our battery. We have to have a complete pathway going through the LED and coming back to the battery. The simple circuit is what they want to start with. Now, they are going to want to start with the fanciest card you can think of. They want lights all over the place, and it's tempting to go for it, just do it. But they have to start with one light. If they try and do parallel, it's not like it's not possible, but if they try and do parallel lights, now they are going to be cutting their copper wire. There's all kinds of variables that are going to prevent it from working. If they have finished one of them, then say, great, go make another card and try with the parallel circuits. But you're going to have a hard enough time doing one. A short circuit means that for some reason, the current's not making it through the LED. If there is a short circuit, which means that the electricity has found another path to go in, and it's going to just go without making it through the LED, it is generally going to get hot. It's generally going to get hot. Now, the amount of power that it's going to get warm, you may not be able to tell, but you will know if there's a short circuit because it's not going to light. There is also a possibility that they may lack a connection, in which case it is an open circuit, and it means that somewhere along the line, something's not touching. Okay, so those are the two major problems that they're going to have in making a simple circuit. Now, I don't remember how long this is.
Hi, in this tutorial, we're going to show you how to get started working with copper
I
tape
have to show this to your girls,
circuit.
you probably want to know.
There are two main types of copper tapes. One has conductive adhesive. This type you can order online. The other has regular, not conductive adhesive. This sort of tape is more common and can be found at your local hardware store. They may look the same, but they function very differently when building circuits. With conductive adhesive tape, both the top side and the sticky bottom side of the tape will conduct electricity. That is, you can stick this tape over a gap in your circuit and electricity will flow through the adhesive and turn your circuit on. This means you can create new electrical connections and extend your circuit just by sticking down one tape over the other.
Boy, she makes it look easy, doesn't it?
On the other hand, with non-conductive adhesive tape, Only the top side will reliably conduct electricity. That is, if you stick this tape over a gap in your circuit, it creates an unreliable electrical connection. As a result, your circuit might flicker, or sometimes it won't turn on at all. Here, you'll need to fold the tape on itself so that the exposed copper is on both sides. Then, you can tape it back down to your circuit, but since the ends aren't sticky anymore, you'll need to tape over the connection with a normal piece of tape to secure everything. Likewise, if you want to extend your circuit using non-conductive adhesive tape, just sticking the tapes together will create flaky connections. As a result, your circuit may flicker or not turn on at all.
Okay, did you guys get that?
Yeah.
So if you've got, and actually even with the conductive tape, it is sometimes, if you're going to connect two pieces of copper together, it is really helpful to simply, double it over itself and tape it down, because it isn't always reliable. I know that she made it look super easy, but I've done that and had it not.
Okay, so if you're having trouble, just double it over and put it.
Yes, the best thing to do as they're making their circuit is to make sure that if they're gonna go around in a circle, that they actually keep that as one continuous piece of tape rather than cutting it. So as much as they can without cutting it. That also means that they have to plan ahead. They're gonna have to think ahead about what they wanna build. But one continuous piece of tape is better. You can, on the continuous piece of tape, if you've got girls who get real anal about it and need the corners to look all level, they can still bevel it and not cut the tape. So just so that you know, they can do that. They can fold it. That's perfectly fine. As soon as they cut it, they cut the connection. So as they're going around corners, beveling is better. If they need to cut it, the one that's on the bottom is perfectly fine, but whatever they're gonna put on top, they need to fold it over so it's copper on copper, not adhesive on copper. And then usually it'll work really well. They will have to tape it down, and they'll have to really make sure that adhesive is really good to make sure that connection is good.
To fix this, at every junction between different pieces of copper tape, you'll need to fold back the ends so that there's exposed copper on both sides, and then tape the connection back down with regular tape to secure it. This way, the connections are much more reliable. Now let's look at the craft side of using copper tape. You'll notice it's basically like regular tape, except made from copper metal so that it can conduct electricity. You can use scissors to cut it, but it's also soft enough to tear by hand. I like to cut my tape in half lengthwise because this gets me twice the length of copper to use, and also thinner tape is easier to maneuver for finer details. Before sticking down the copper tape, you'll need to remove the paper backing. I've found the easiest way to separate the backing from the tape is to run the pad of your finger against the edge until the tape peels off. When cutting your tape in half, you can cut evenly and produce even straight lines, or you can feel free to play around and create curves or any designs that you want so that your tape is different widths. Here I've cut a wavy pattern. If you want to turn sharp corners with your tape, try this folding technique. First, flip the copper tape over opposite your turn so that the sticky side is face up. Then flip the tape back down in the direction of your turn. Finally, flatten the corner and you've got a nice clean turn. You can create any angle you want using this fold technique. Try making your own zigzag pattern. In addition to sharp corners, you can also make smooth curves with your copper tape. The trick is to first stick the copper tape down so you have an anchor, and then crease the tape slightly so that it turns a little bit, and then flatten. Continue creasing slightly and then flattening as you go along the tape. Pretty soon you'll have a curve. The more sharply you turn at each step, the tighter the curve. To flatten the wrinkles in your copper tape, you can use a smooth object like the plastic handle of scissors to work the wrinkles down into the paper. I've found that the thinner the tape you use, the easier it is to make tighter curves. Try experimenting with different widths and see what patterns you can come up with. Once you're comfortable using copper tape, try crafting circuits. You can make different designs or even write messages with your circuit. You can also bend or fold your circuit like this circuit origami. Try taping your circuits onto other objects, like your favorite mug. You can even use circuits to decorate your room, like this window mural. Find projects and more tutorials like this one at chittytronics.com. Thanks and happy crafting!
All right, so you can see, you can get very fancy. And they, actually, it's surprising, they don't like the way the circuit looks on the inside of the card. So they want to make until they can't get it to light, and then they don't care and they put it everywhere. But they do like it to look kind of fancy on the inside as well. So this is the simple circuit template, okay? That's what the actual LED light looks like. You can see it's labeled positive and negative, but it's very difficult, it's really tiny, and it might be helpful just to have that up on the screen. But this is the simple circuit. Now, they've got this lined up this way, where it's coming up, and then there's a gap, and then it's going to the other side. I have found that this little gap here sometimes gets screwed up for them, for whatever reason. So it is easier, I think, to make, have one come on one side and then kind of move it over a little bit and then put the LED in between. That seems to work more consistently. And then, right, get the little lights and they can decorate the front. Now, the other thing that I suggest is that they showed on the video where they have the little LED light there and it's pinched on there so that it's constantly on. They're gonna drain these really fast if they do that. So it is better for you if they are simply testing it out. That little line across there is a folded corner. A lot of times the girls don't like the folded corner. They don't like the way this looks. Just so that you know, it's possible to create a small tab that comes off to the side so that it's kind of sticking out, and then you can fold the tab so that the card still looks like a card. Does that make sense? I suggest that they do this part first. Don't decorate until the circuit is working. And then they can actually feel the LED light there and push it through so that they can see where that is and then make a little hole in the card, and then they can decorate the card. Does that make sense? That would be my suggestion. Some of them are gonna plow ahead and do it any way they want, but I would insist one circuit start. So we have time for you to make a working model. You need a model because then you can lay this out and go, look, this is how it works. And they can come up and take a look at it because it's surprisingly difficult to do. Just telling you, it's surprisingly difficult to do. I would also suggest that you pass out a piece of copper tape that's about a foot long and ask them to use that foot long piece. And then as they go, oh, I need some more, then you can dole out the other part because otherwise you're going to be throwing away a lot of copper tape, which is a huge waste. All right, everybody ready? Everything that you need is over here. I have LEDs up here. And actually, Carol, do you think you could cut some copper tape?
Right now.
Actually, sure.
You'll get credit from now until.
We got there. We still have to file. So if you guys want to share what's on here.
Google Sheets or something. Because you could actually sort it.
Yes.
And then easier, or like if A12 wanted to like upload it.
Yeah, no, I like Google Sheets.
Okay, so these are colors. If you look on there, you can see blue, red, yellow.
It shows that Google Sheets are
Oh, there's the
Oh.
You may need more. So if you want to apply more. Yeah, if you feel like you really want. Battery goes here. Red, blue, and yellow. And I have white, we have, oh no, they're all colors. Surprisingly, our girls wanted white.
Really?
More of the white, they wanted the white, I don't know why. Oh, I guess that is. And then I have the electrical. You can be in charge of the art.
What color LED? Red and red and yellow.
Yeah. What do you think? That's what I was thinking. Just a suggestion that you guys might want to think about some simple things that they can draw on there that might light up, because some of them are going to sit there going, no idea what to do. Or get too carried away. Or they get too carried away. So like these lightning bugs, trees, flowers with to put it in the middle of the flower, raindrop, a cupcake with a candle that lights up, a lantern. All okay, and my model's up here in the front, so. I actually did make it circle. I'm so bad at this. It does. I think it does. So
Great lines, good.
Draw that card, do the circuit first.
I went like years ago.
Yeah.
I never did it. It was like all. It was like, you
So what they mean. Right. Circuitry. Oh, this is right. Because depending on how much I
And
have.
closes it on top of it.
So if you're making a card, how do you do that full?
You have to be very strategic. I usually have. Cut this off. Actually, what you come to, bring this guy down. There we go.
Battery. On this side. And now, can I just make it go straight? Yep. I sort of like from there to there. Touch that.
Something simple. Something
like
simple. Actually, what the flower, make the circuit first, but think about where you want your LED lights to be. And keep in mind, and I might make your, I might like make.
She said that.
That's what it makes it a little clearer rather than the whole sheet. So you want to cut that.
So there's separate.
And then.
No. I thought I was being so simple. This is tricky.
So you're gonna have, if you look at the way that is.
Okay,
And.
now is the troubleshooting part.
So.
The corners are connected.
There you go. And then however you decide to do the rest of that diagram there. So this is
Where's the
what I
battery?
do here is copper tape.
I don't.
Appreciate that, thank you.
I don't think there's a battery.
Yeah, there's
Well, is it in here, right?
no.
No.
You need a separate
I need a
button.
battery.
Yeah.
You
Thank you.
Okay, so this is one, we try and let the girls explore as much as possible with everything. This is one of those places where, I think that they can explore with it, but
Hang on a sec. Can you do it one more
they
time?
get so frustrated when it doesn't work properly that
Can't even see
giving
the
them
light on the
tips
front.
as to what to do to start, it seems like we're telling them what to do, but you're really not, because you can see, even with the diagram and all of that, it's still pretty challenging to get it to light. The exploration here is really more troubleshooting.
I'm missing something.
It doesn't really matter, but remember that the copper wire is going to have to be under the battery and on top of the battery. Because if you look, right, so the reason why this is in the corner is that allows this to be on top of it. But if you look anyway, just to give you guys an alternative here, this is also going to light. You can see that they've got a hole here and they put those two strips, and when you fold it over, this also works. This is an alternative. It doesn't look like a circuit, so it's a little bit more difficult to kind of like get in your head, but it still completes the circuit if you look at it carefully. But some girls, if they're having trouble with it, having those two strips, you just have to make sure that that strip that goes up into the corner is aligned so it can come down on the battery. Does that make sense? And these are all in the PowerPoint, along with, if you look here, right, there are some other alternatives in the PowerPoint, and there is a website to these people who do the little LED lights so that you can go and examine it.
So,
You would, yes, you use one of those.
Oh,
Yes, but be careful because
It is going to fold it in.
And like that, and like that. So you have a third piece.
Okay. Anyone need help? Okay.
At first I thought
And actually, I've had, you know, where do you want your, figured it out, they go to town.
Well, I want you to put a couple different.
She's doing the one
Yeah,
on
tape here, but not too much because each end of the copper should touch that LED. Okay. I gotta reduce those. I would go a little more.
As you guys are thinking about this, depending on when you do it, we ended up trying to hold off on this and did it on Valentine's Day. Or like close to Valentine's Day. Or you could do it close to any holiday. Even if you haven't done electricity in a while, you can still come back and do it. So,
Of the gold is here and the other tip is there.
No, that's okay. I was like, I'm getting something.
From one end and that other gold point
Okay. So now.
Okay. Now, where are you gonna put your gold?
Where this is.
Probably here in this corner. Because if you want to yeah, need something. How do I do that? Like, further on the outside.
So you wanna, like she said,
Like, the line is like.
So you're like another
wire.
And
down.
So look at.
I've got my one that goes here,
Uh-huh.
and then I got my one that goes here.
And then the light goes over the positive.
that way, now we want to start
And this
this
is just
here.
Where the light is.
So the light,
So
I
I
remember
would-
they were talking about.
Beautiful. Would you like to see our happy birthday cake?
Ooh.
So you're gonna, you wanna, the battery.
And this-
Otherwise,
Right,
right,
the side's gonna be placed, this area, this area, this area. So try it. Let's see here. Maxine, sure.
Then you just build copper wire
And then this is where our battery.
and then the batteries.
So.
Well, I'm gonna.
It's a long time.
Training.
And then you can
get in.
Yeah, right here, you go down to come across. Yes. So leave it at,
This has to be
something like that, sir. And then just make sure when this folds, and then eventually just like, so you have a total like two, yeah, one where the light will make and then one where the battery will make the fluctuation between the two. And then since your light is here in the corner,
Battery stay on here.
maybe that's a little bit.
So we'll do.
Yeah, exactly, yeah.
Exactly.
And something where the battery will touch like. So when this folds over, no, I was doing that one time. So when this folds, this piece here will touch that and then that's.
This is your, this is your negative, that's your positive. So this one needs to be.
I'm basically going once. I can't help it. Yes, I can. I'll be kidding you.
And that's just, again, just go right on top of it.
Oh,
Yeah, and if it goes over it, it'll pass.
David,
I need some too, but.
Okay, now.
Actually, it all depends on.
So I'm wondering if,
Yeah, I mean, I went over mine a few times and then push the right down.
Yeah.
Oh, yeah, let's look
yeah.
I got this add on some more space.
You can add our data, but when you do it, make sure that you bend those ends, so it, so like copper's touching copper.
Okay, maybe.
Go for it.
Let's go.
I didn't realize at first.
Part of this matter, so it's like have to touch everything.
Yeah, I don't know.
Okay, more though.
Like the.
Oh, you know what? Yeah, has more rapid. I think that's it. Yeah,
So this goes here like this.
because the whole height itself should be exposed. See how there's no big
This is one over on the top of it and one on the bottom of it, correct? So
Yeah.
this.
Yeah, that.
And then you take the-
Yeah.
You take it to one side.
Negative side. Yeah. So my whole arrow for
Trying to make it less, make it stand out.
You can. Don't get more. Why don't you try, just because I don't know from it, let's try doing it in one straight piece rather than a corner. Because it's long, right, so it needs to get. And if you want to, show you the whole piece if you want to. But she did say like one continuous piece is better
Oh,
than
yes. But.
the least on the grace. Yeah, this is a piece. Because I want the lower you decrease.
So
the-
that's to say, this is.
That's what happened, like, regular tape, yes, regular tape, like, right there on the stove, let's just.
Yes. Let's try that, but you will still need to come back. And then,
Yeah. I have no idea.
Yeah, maybe get there and then connect.
Horrible person.
So you at least remember how to do it.
Yes.
Yeah.
I will do that.
Alright, how's it going? Down.
These problems we
Oh, there you go. That's good. Remembering that.
So,
Mine should be.
so too close, so maybe those are too close. Because
So the lights
the coppers too close to each other can short each other.
Cause they,
So
the
like,
light should be on this.
Then you decorate.
Yeah.
So.
Double light. And we can get you new like it's not super sticky.
I got it.
I know. Of all the times I've done it, today this is the first time I've done it.
Which makes sense if you're red eyes anyway, so you almost want to be on yellow paper anyway, so the perfect.
So my whole.
Hold on, let's see.
So, what does this mean? I would do first.
I don't know if we want these touching at the same time. So like that there.
this right now?
Yeah, is there anyone who has not gotten their LED lights?
Right here.
Yeah.
I'm not quite
I'm not 100% sure.
Give a little bit of extra. Right. It's going worth it. Yeah. Or.
This is one huge.
Okay, so that's almost flickering.
If I have it, yeah.
I'm pretty proud of
Very proud of how much.
Feeling impressive on the light a little more?
All right, how's
So that's that flickering.
This one is not. How do I use it? I can keep it. If I make a mistake like that and I stuff like that.
Yes, I think we need to put tape over it to secure that. Was this one that you peeled off somewhere? You can peel it off and put it back on?
Right.
Okay. Okay, so that because this has got a positive and negative sign on it. So this negative, right, this is the positive side, so negative coming in. So that is actually a good point. Ladies, as you are doing, as you're troubleshooting with the girls, one of the common problems is that, remember that there is a directional flow on that LED, and there's a directional flow on the battery. So if it's not working, it may just be as simple as flipping the battery over.
Yeah.
Right? So that should be like the first thing you think of. Let's flip the battery over, see if it won't work that way.
So the
And
work.
it's better than
hold
I'm pretty proud of my bench and then,
Yeah.
You're welcome.
these are so finicky. This is why it's so frustrating.
Big
So we did have it. Till we get the tape. And the tape's supposed to help. What do we do?
Kathy, does it, when you have the tape like crossed over with like excess, does that make a difference? Like, see how there's a little piece here, a little piece here, because this was not a continuous piece.
No, but I'll tell you what, right now, you may not have copper on copper, you probably have copper on
And
it.
tape, right.
So if
Which
you,
one is copy and tape? So
So both of these are copper and the tape is underneath them, but when you put the tape over that, the glue, the adhesive is what's sticking, not the copper.
Well, it was
That
working
is right.
before, but,
Well, maybe that's why it was flickering,
okay.
so.
So let's try to, so what do we do?
That's probably why they say a continuous piece is probably better than none. So flipping it, maybe turning it, and having a copper on copper, and then maybe we can get some tape to seal that. Otherwise, when in doubt, start over.
It's not coming up. Remember, before we put the tape on, it would come on a little
Right.
bit.
Well, let's try this since we're trying to get that copper contact.
No, now it's not coming out. So I don't know what to do. I don't know. Now that's it. So I don't know what happened, because it was coming on, but I don't know why it died.
Well, here, why don't we do this? Why don't we get you another piece of tape? Do your design the exact same way, but do it with one piece rather than breaking the piece.
yeah.
Okay. So I need
So you can see that this is a challenging
Mhm.
thing to
Yeah.
do.
Yeah, it was
All right,
working
so you
until
got
you
yours
take
on?
this down,
Uh-huh.
and then it stopped
And then
working.
just
It was
add a
okay,
thing.
and then
Clear
it was working when I held this down. When I put the tape over, it stopped. But still, the tape should have helped.
The tape should have helped it.
But the tape didn't help.
Okay, here, hold this on for a second.
But it was flickering. So that's.
Well, is this one piece or two?
Okay, so
That's
I'm gonna
two pieces.
suggest, let's try
Do that
this.
again.
Let's do. This. And let's just bypass the whole darn thing.
What about this one here?
We can try that too.
That one
Do we have another little piece of tape? Let's
I can get some.
Tape or copper? You need to look at copper.
wait.
She twisted that.
She did, but we're gonna try doing this a slightly different way.
You want
Sometimes
copper on this one.
we
She
want
was copper
copper.
on top with the next to the
copper on
copper.
copper.
Oh, okay, I see how you're doing it now.
All
Let's
right,
see.
let's see if that works. Put that on there.
There we go.
Oh, okay.
You just have to have
So they're
copper.
just a
It just
little
was
more
not
of a good.
contact. Yeah,
Okay.
there's just, the
But
contact
that's
was
good
not
though, the
enough.
troubleshooting is
So I'm gonna
just-
write down the
Yeah,
adhesive we gotta be careful of.
Just make sure it's copper on top of
Okay.
copper.
The copper tape, regular tape is right there on the ledge of the counter over there.
Yeah.
No, right here. Right under the Oh, thank you. You're welcome. One last little bit of troubleshooting. If you notice that, like, they've got their circuit on there and it's still not working very well, and you suspect that it might have something to do with a corner or something like that, or contact, if you were to take a piece of the copper tape that is twice the length of, say, a corner, and actually here, I'm gonna just kind of cut it. Let me see here. So if you were to take a small piece of copper tape, take the adhesive off, and then fold it in half on top of it so that there's copper on the top and copper on the bottom, and then just put it across where you think the problem is, it will create a new pathway for the electricity, and sometimes it will solve a problem that you just don't know why that's happening. And it usually has something to do with the adhesive, but you may not be able to fix it. But if you get a whole nother piece of copper and just bypass that problem completely, it'll just go through. So sometimes they just have to start over. So just be prepared for that. All right, do we have any questions on paper circuits? Okay, I do want to remind you on the very last slide of this PowerPoint is the website for the people who make these lights. These are the same ones you're going to be ordering, correct? So they have all kinds of videos on, how-to videos on there. They have ideas on there for different kinds of circuits and cards. So feel free to go and browse. All right. Yeah, you can cut it. Unless you want, well, the flashlights, do you want that to be a separate thing? It's really good. Okay, then yes.
Okay, and then before we start with our last activity, which will be an extension of these paper circuits, I am gonna ask that you review the slide